3 minutes ago, the Virtual Telescope project released brand new images of 3I Atlas, and what they captured has left even NASA speechless. This isn't a rumor. This is confirmed. The most mysterious interstellar object ever found has done something that science cannot explain. And by the end of this video, you'll understand why the world's top observatories have quietly gone into alert mode. Before we dive in, tell me, where are you watching this from? Because right now, the same patch of sky you see tonight might be home to something not just passing by, but watching back. Hit that like button so the algorithm knows you're part of this discovery. And subscribe. Because what you're about to hear will change everything we thought we knew about the universe. On November 5th, the Virtual Telescope project released 2 fresh images of 3I Atlas, the third confirmed interstellar object ever recorded. And those frames have already rewritten everything we thought we knew about celestial physics. The observatory's array caught the intruder as a compact, unnervingly steady point of light, gliding across the black ocean of space, its luminance fixed, its surface unchanging, as though it were frozen in time. When the new data was placed side by side with Hubble's images from July 2025, astrophysicists expected to see an obvious transformation, an expanding coma, a brighter halo, or the faint whisper of material peeling away as the object endured the hellish radiation near the sun. Instead, they found almost perfect symmetry. No tail, no plume, no sign of a body shedding the billions of tons of gas and dust that should have been vaporized during its perilous perihelion pass. To the human eye, the contrast between the two datasets looks almost eerie. The July frames showed a dull glint of reflected light, an object behaving roughly within expectation for a comet nearing solar proximity. But the November photographs, taken after what should have been the most violent phase of its orbit, reveal a surface that remains as calm and intact as polished stone. Astronomers compared the readings and realized that 3I Atlas had lost virtually none of its brightness or structural coherence, an impossibility under known physical laws. According to Harvard's Loeb, the math alone makes this scenario absurd. A mass exceeding 30 billion tons passing within intense solar flux should have boiled off at least 5 billion tons of volatile ice and silicate matter. Yet, the telescopes recorded silence. No blooming debris cloud, no visible emissions, no plume of energy or radiation. Even the reflected spectrum defies logic. The Virtual Telescope's sensors captured a tight white-blue luminance, clean, controlled, as though the object were generating or channeling light rather than merely reflecting it. When researchers calibrated the data against Comet Lemon, a textbook example of a body shedding gas under radiation pressure, they were confronted with a shocking dichotomy. Lemon displayed the expected glowing tail, a translucent fan of vapor driven away from the sun. Atlas, by contrast, was stark and surgical, its edges sharply defined. No haze, no dispersion. It should have been shedding fire, but instead it hovered in stillness, cloaked in an impossible calm. To the astrophysics community, this was not just strange, it was humiliating. The numbers refused to fit any natural model. The calculated outgassing required to explain its acceleration would have created a tail bright enough to outshine Jupiter, visible even through modest backyard telescopes. And yet it wasn't there. As Loeb himself remarked in a late-night interview, if this is outgassing, then we are missing the gas. Other scientists, from Caltech to the European Southern Observatory, echoed the same disbelief, their statements alternating between fascination and unease. One researcher, speaking anonymously, said, "It's like watching a candle burn that never melts." The deeper they looked, the stranger it became. High-resolution analysis suggested a surface temperature that remained surprisingly stable despite the solar intensity, indicating some form of heat regulation or material resilience beyond any natural composition we've catalogued. The object's spectral fingerprint, dominated by nickel and depleted of iron, already set it apart from every known comet or asteroid. And the new imagery reinforced the idea that 3I Atlas was not behaving as a passive traveler, but as an active system. Some speculated about unknown minerals, others whispered about engineered alloys, but no one could reconcile the data with standard cometary physics. What made the stillness more haunting was its precision. Natural objects tumble, spin, and flare as they release pressure. Comets are chaotic by nature, but Atlas glided through the void like something in deliberate control, unbothered by the sun's fury. It was as if the universe had paused around it, as if the laws of motion had been momentarily suspended. Scientists plotted its light curve, expecting jitter and decay, yet the graph returned a flawless line. In a universe ruled by entropy, this kind of steadiness borders on defiance. By the end of that day, forums and research servers were buzzing with the same uneasy question. If Atlas was not changing, if it refused to erode or react to heat, then perhaps it was not made of anything we understand. The virtual telescope's clean, featureless data forced a grim conclusion that even seasoned astronomers hesitated to voice aloud. The silence of its surface, the refusal to lose mass, the polished geometry of its reflection, these were not signs of decay, but of intention. And as one scientist quietly typed into the project log that night, "Whatever 3I Atlas is, it's not playing by nature's rules." On October 29th, during its critical perihelion passage, 3I Atlas performed an act so subtle and so precise that it forced NASA's Jet Propulsion Laboratory to rewrite its predictive models overnight. The event was small enough to be dismissed at first, a deviation of only 4 arcseconds from its expected orbital path. To the casual observer, that number sounds insignificant, a fraction of a fraction in the vast silence of space. But at a distance of 200 million kilometers from the Sun, that whisper of an angle translates to a displacement of nearly 80 kilometers, as though the universe itself had blinked and the visitor had quietly stepped sideways. The tracking data from JPL's Deep Space Network confirmed what no gravitational calculation could justify. The interstellar body had shifted course without any external influence strong enough to explain it. In simpler terms, something had nudged it, something precise, deliberate, and invisible. To understand the scale of this defiance, imagine firing a bullet across an entire continent and watching it suddenly curve mid-flight, without wind, without resistance, without reason. That is what Atlas did on October 29th. Celestial mechanics dictate that interstellar objects, especially those on hyperbolic trajectories, move predictably, their paths sculpted solely by the sun's gravity and their own inertial velocity. Once a trajectory is mapped, it becomes as reliable as mathematics itself. Deviations of this magnitude are unheard of unless an external force is at play. Yet, the telemetry told the same story from every vantage point. Chile, Hawaii, La Palma, Mauna Kea, and even NASA's infrared array in California all recorded the same divergence, the same inexplicable acceleration vector. What stunned the analysts was not only the direction of motion, but its duality. Atlas didn't simply accelerate away from the sun, it also drifted laterally, as though a gentle yet controlled impulse had adjusted its orientation. The outward thrust measured at roughly 135 kilometers per square day, equating to a monthly displacement of about 60 kilometers. But the sideways component was just as significant, around 60 kilometers per square day, implying a coordinated vector push. It was not chaos, it was choreography. For a naturally tumbling comet, such simultaneous acceleration in 2 perpendicular directions should be physically impossible. The forces required to accomplish that would demand a release of energy on the scale of industrial propulsion systems, yet all telescopes remained blind to any gas ejection, plasma discharge, or visible reaction. NASA's public statement tried to frame it as an anomaly in gravitational modeling, a diplomatic way of saying, "We have no idea." But within private research channels, the tone was entirely different. The analysts working on orbital simulation at JPL and Harvard's Astrophysics Lab couldn't ignore the precision. Random outgassing, the standard culprit behind cometary acceleration, produces chaotic jittering impulses, tiny rockets of vapor venting unevenly from frozen fissures. They make comets wobble, not glide. Atlas, on the other hand, moved with mechanical elegance, its trajectory forming a smooth, deliberate arc, as though guided by gyroscopes rather than chance. It was, in the words of one Caltech researcher, the first celestial object we've ever seen that moves like it's being piloted. The most unsettling part was how consistent the deviation was across instruments. When NASA's deep space radar recalculated the orbit using independent parallax data, the deviation remained intact to within a tolerance of less than 1%. That kind of precision does not belong to nature. It belongs to navigation. The idea of an interstellar comet capable of altering its path with that kind of accuracy borders on the absurd, and yet the evidence continues to compound. Harvard's Loeb, who has long argued that certain interstellar anomalies may represent artificial constructs, summarized it bluntly in an internal email leaked days later. This isn't random drift, it's navigation. For days after the data release, message boards, observatory logs, and private forums lit up with disbelief. The world's best orbital modelers ran simulation after simulation, adjusting for solar wind, gravitational perturbation from Jupiter, even speculative interactions with unknown magnetic fields. But every scenario collapsed under the same constraint. The object's acceleration was clean, directed, and synchronized with no detectable external trigger. It wasn't an explosion or a leak. It was an adjustment. The longer scientists stared at the numbers, the more the object seemed to behave not as a natural wanderer, but as something responding to its environment with awareness, or at the very least with purpose built into its structure. When visualized in simulation, Atlas's trajectory appears almost graceful, a slender curve diverging slightly from its predicted route and then stabilizing again. Perfectly balanced, perfectly timed. To many, it looked less like a deviation and more like a correction, an intentional recalibration, the kind of maneuver a spacecraft would execute to align itself with a target vector. Some dared to whisper that maybe the object had reacted to something near the sun, using the intense gravity well as a slingshot or as an energy point for a burn, the same way human spacecraft exploit planetary assists to save fuel. If that were true, then Atlas wasn't merely passing through the solar system. It was using it. For those who have spent their lives mapping the heavens, the event of October 29th has become a wound in the logic of astronomy. It forced open a question that should never have needed asking. Can an interstellar object choose its own path? For now, the official stance remains conservative. Unexplained, under review, pending further data. But in the quiet corners of observatories and academic chat rooms, a more radical interpretation has taken hold. Perhaps Atlas is not obeying gravity because it was never meant to. Perhaps this perfect silent traveler is not drifting aimlessly at all. And if that's true, then its destination, whatever or whoever it may be, has already been chosen. In the natural order of comets, there is one rule that has never been broken. When an icy body approaches the sun, it bleeds light. The heat transforms frozen gases and buried volatiles into plumes of vapor that burst outward, carrying with them dust, metal fragments, and the faint echoes of a chemical storm. This is called outgassing, and it is the lifeblood of cometary motion, the phenomenon that gives rise to their brilliant, ghostly tales. By every calculation, 3I Atlas should have obeyed this ancient rule. Its immense mass, over 30 billion tons, combined with its close solar pass, should have resulted in the release of more than 5 billion tons of gas during the weeks around perihelion. To put that number in perspective, that's equivalent to an entire mountain's worth of material vaporizing into space, creating a halo of dust large enough to dwarf the planet Mercury. It should have been visible in the simplest of backyard telescopes as a radiant, spreading fan of light sweeping behind it. But the universe had other plans. The telescopes, ground-based, orbital, infrared, ultraviolet, watched and waited. The James Webb Space Telescope aimed its instruments at the object during its critical window, sensitive enough to detect a wisp of water vapor at one part in a trillion. The European Southern Observatory's VLT focused on the wavelengths associated with hydrogen and carbon dioxide, the signatures of sublimating ice. Yet all of them found the same result. Nothing. No luminous trail, no particle plume, no faint corona glimmering in reflected sunlight. Atlas remained, as one analyst poetically described it, too clean for its own good. Even the most modest, dust-choked comet forms some measure of visible scattering under solar radiation pressure. But Atlas defied the principle entirely. It looked inert, yet somehow it was moving faster. The comparison with Comet Lemon became the defining example of this absurdity. Both objects were observed under similar thermal conditions. Both experienced similar exposure to solar flux. And yet, Lemon blazed with predictable beauty. Its tail extending hundreds of thousands of kilometers, a transparent veil of ionized gas driven outward by radiation pressure. In contrast, Atlas glowed as a single tightly contained sphere, its edges sharp against the void, its spectrum unnaturally blue. Where Lemon's body diffused under solar heat, Atlas appeared to condense, almost as if absorbing energy rather than releasing it. The lack of any diffused emission or reflection pattern contradicted centuries of observational astrophysics. It's like seeing a bonfire that doesn't emit smoke, one researcher noted during a closed NASA briefing. For comets, the physical explanation is simple and mechanical. Outgassing acts like 1,000 microthrusters firing unpredictably across the surface, pushing and twisting the body as gases escape. But 3I Atlas displayed the acceleration of a thrusting object without any evidence of reaction mass being expelled. The infrared bands showed no heat plumes, no chemical trace of vented volatiles. The natural explanation began to collapse under its own weight. To generate the observed momentum, the body would have had to vent more than 5 billion tons of material in less than a month, which would have flooded every visible and invisible wavelength with overwhelming light. The night sky should have shown a blazing streak brighter than Jupiter, but instead the object remained dim, serene, motionless in its outward appearance. When the data reached Harvard's astrophysics department, Avi Loeb and his team reran the photometric calculations and confirmed that the numbers left no margin for error. If outgassing caused this, he wrote, we would be seeing the comet with our naked eyes. This meant one of two things. Either the acceleration was not caused by ejected gases, or the gases themselves were not of any kind we had ever detected. Some proposed exotic physics. Perhaps Atlas was venting ionized metals invisible to common wavelengths, or perhaps the object was encased in a shielding layer that trapped emissions internally. But these were desperate theories, stretching known science to its breaking point. As the silence in the data deepened, a darker hypothesis began to circulate, whispered first in private scientific forums and then more loudly across the public space community. What if Atlas was not accelerating naturally at all? What if the energy pushing it was not the product of random venting but of design? The lack of gas emission and the steadiness of its course pointed toward an engineered propulsion system, something akin to a plasma drive, an electromagnetic sail, or even a photon propulsion array operating on principles humanity had only begun to test in laboratory conditions. Plasma jets, by their nature, can operate silently in vacuum, emitting wavelengths that would be nearly invisible to optical telescopes, but unmistakable in their directional precision. An electromagnetic drive, on the other hand, could produce continuous thrust without expelling reaction mass, bending the rules of motion through field manipulation rather than combustion. And if 3I Atlas possessed such a system, if it were capable of propelling itself smoothly through the inner solar system, then it was not merely a visitor. It was a craft. No scientist has dared to call it that outright in official papers, but the tone of recent reports has shifted from cautious analysis to quiet alarm. The object's smooth, radiant exterior could easily conceal internal field generators or superconducting frameworks designed to channel solar energy directly into motion. Its nickel-rich composition, coupled with the near absence of iron, is consistent with industrially refined alloys used in advanced aerospace design. When placed under that light, the entire puzzle begins to align with uncomfortable coherence. Every absence becomes a clue. Every silence becomes a signal. And that is the paradox that haunts this investigation. The more we fail to see, the more the evidence points toward intention. There is no natural mechanism that explains the acceleration of an object this massive without leaving a trace. No comet can hide its own exhaust. No rock can choose to remain cold under fire. If this isn't nature, then someone, or something, designed it to move. The deeper scientists dig into the data surrounding 3I Atlas, the stranger the story becomes. By the end of October, the list of irregularities had grown so extensive that many institutions quietly stopped calling it a comet at all. What began as a series of curiosities, minor deviations, odd light curves, slight composition discrepancies, has now hardened into 9 full-blown anomalies, each one shattering the expectations of physics and deepening the suspicion that this interstellar visitor is something unprecedented. The first anomaly is known as the impossible. Path 3I Atlas should have approached the solar system from a random direction. Interstellar objects are cosmic drifters, entering our system on paths dictated purely by chance. Yet Atlas's orbit sits only 5 degrees off the ecliptic plane, the very flat sheet in which all the planets travel around the Sun. The odds of an object from another star system aligning so neatly with that cosmic disk are statistically microscopic, the equivalent of tossing a coin across the universe and watching it land perfectly upright on its edge. Astronomers describe it as a cosmic sniper shot, a trajectory so precise it suggests purpose. If gravity alone were responsible, the entry would be chaotic and steep. Instead, it glides like a traveler following a predetermined highway through the solar system, slipping between planetary orbits as though tracing a path it already knew. The second anomaly, the physics-defying jet, shattered every rule of cometary behavior. In July 2025, multiple observatories recorded a narrow plume of material bursting from Atlas's surface, but not away from the Sun, as every known comet tail does under radiation pressure. This one was aimed directly toward the Sun, an act of cosmic rebellion against the very forces that shape celestial motion. It is as though the object expelled material forward, into the solar wind, an act requiring energy input rather than passive release. Nothing in physics allows such a phenomenon without a guiding mechanism. The metaphor repeated among researchers was stark. It's like watching a runner with their hair blowing forward. Then comes the mass paradox, the third and perhaps most unsettling anomaly. Atlas is far larger and denser than any previous interstellar object, weighing in at nearly 33 billion tons, 1,000 times heavier than Borisov, and 1,000,000 times more massive than Oumuamua. Yet it travels faster, not slower. In astrophysical logic, the more massive an object, the more inertia it carries, and thus the more sluggishly it should respond to external forces. Atlas, however, behaves as though weightless, gliding effortlessly across the void. The implication is simple but horrifying. It is moving under an influence that negates inertia itself, an internal energy source overriding gravity's grip. The fourth anomaly, perfect timing, raises questions that border on paranoia. During its solar approach, Atlas passed near Mars, Venus, and Jupiter, large, magnetically rich worlds, ideal for observation. Yet it avoided Earth with almost surgical precision. Its perihelion occurred when it was completely hidden from our vantage point by the Sun, meaning no ground-based telescope could observe the crucial moment. The coincidence is so unlikely it borders on strategic. As Loeb remarked during a Harvard symposium, if someone wanted to conceal an operation in the solar system, they would schedule it exactly as Atlas did. Closely linked is the fifth anomaly, the pre-calculated route. When orbital reconstructions were plotted backward, scientists discovered that Atlas's entry vector intersected near perfectly with the gravitational wells of several major planets, as if taking advantage of their pull for guidance or data collection. It did not wander aimlessly. It slingshotted gracefully, sampling gravitational gradients as though following a reconnaissance plan. Even skeptics admitted that its path resembled that of a probe performing a survey flyby, measured, efficient, and deeply aware of its surroundings. The sixth anomaly lies within its substance, the nickel-alloy ratio. Spectroscopic analysis revealed a bizarre imbalance between nickel and iron, with nickel concentrations far exceeding natural norms. This ratio is virtually unknown in unprocessed materials, but strikingly similar to engineered alloys, like Inconel, used in human aerospace technology for high-temperature resistance. In short, its metallic fingerprint mirrors the kind of refined composition we use in jet engines and spacecraft hulls. To suggest this formed naturally stretches credibility to breaking. To call it manufactured seems almost rational by comparison. Then there is the desert dryness, the seventh anomaly. Comets are often described as dirty snowballs, their masses dominated by frozen water and methane ices. But 3I Atlas contains less than 4% water, drier than the Sahara Desert, drier than the lunar surface. At its distance from the Sun, that level of desiccation makes no sense unless the body's surface is sealed beneath a refractory shell, perhaps metallic or ceramic, designed to withstand heat and prevent sublimation. If that is true, then Atlas is not melting because it cannot melt. The eighth anomaly, the polarization pattern, emerged when infrared polarimetry measured its light scattering. Natural surfaces produce chaotic, diffuse polarization signatures. Atlas, however, returned a sharply organized pattern, symmetrical and consistent, almost as if reflecting from flat, engineered panels. No comet or asteroid in recorded history has displayed such a fingerprint. The reflection resembled polished metal rather than rough rock, prompting speculation that we are observing some kind of structured surface, perhaps plating, perhaps a solar array. Finally comes the thermal anomaly, the most extreme violation of all. Atlas shines bluer than the sun, indicating an effective emission temperature exceeding 5,800 Kelvin, hotter than the photosphere of our own star. There is simply no natural explanation for a non-stellar body generating that level of energy without disintegration. The only possible interpretations involve advanced radiation control or internal power generation. In short, it glows not because it burns, but because it's active. One by one, these 9 impossibilities pile into a single, disquieting truth. A perfect orbit that shouldn't exist. A jet that defies solar wind. A mass that moves as if massless. Timing too exact to be random. A path too efficient to be accidental. Metals too pure to be natural. Dryness too severe to be cosmic. Reflections too polished to be stone. And heat too intense to be inert. 9 anomalies. One conclusion. Either physics itself is broken, or this object isn't from nature at all. When astronomers first encountered Oumuamua in 2017, they thought they had glimpsed the strangest thing the cosmos could offer. A cigar-shaped wanderer that spun erratically and accelerated without a visible tail. 2 years later, Borisov followed, an icy traveler that at least behaved like a traditional comet, glowing and shedding gas as it crossed our sky. Both objects challenged our understanding of interstellar visitors, yet they still fit within the elastic boundaries of physics. 3I Atlas, however, doesn't fit anywhere. It doesn't bend the rules, it breaks them. Where Oumuamua teased us with mystery, Atlas stares back like an unsolvable equation, one that mocks our science and our arrogance in believing the universe should be predictable. With Oumuamua, scientists could cling to the edges of reason, perhaps a thin shard of nitrogen ice, perhaps a pancake-like body reflecting sunlight at odd angles, perhaps even frozen hydrogen sublimating invisibly to push it forward. But Atlas laughs at all of those excuses. It is larger, heavier, brighter, and colder, and yet it moves with the grace of a guided machine. The same mathematical frameworks that strained to explain Oumuamua's strange acceleration collapse entirely when applied here. Every data point seems to reject the next, like puzzle pieces carved from different sets. Scientists accustomed to certainty now face the most uncomfortable truth of all. There is data they cannot fit into equations. The universe, for the first time in modern memory, is producing numbers that refuse to obey. In conference halls and remote observation centers, the tone of conversation has shifted from skepticism to unease. The astrophysical community has spent decades building the illusion of mastery over the cosmos, of being able to explain every light curve and orbital drift through the pure elegance of mathematics. But Atlas shatters that comfort. It is not only the anomalies themselves that are unsettling, it's the pattern they form. Each discovery, from the metallic composition to the precise orbital deviations, interlocks with the next in a way that feels constructed, deliberate. When you lay the data out end to end, it doesn't resemble a random scatter of observations. It resembles a blueprint, a sequence, a system. It is as if the universe has written a message in motion rather than in words, and humanity is struggling to read it. Avi Loeb, long considered one of the few scientific voices willing to entertain the extraordinary, summarized the dilemma with disarming simplicity. When data doesn't fit theory, question the theory, not the data. His words have rippled through every corner of the astronomical community. Many researchers still resist, still cling to the comfort of natural explanation. But Loeb's argument is clear. Refusing to accept what the data shows is not skepticism, it's denial. If the physics fails, perhaps it's because we're missing something fundamental, something larger than the framework of our current understanding. For centuries, science has been built on humility before nature's mysteries. Yet Atlas feels less like nature's riddle, and more like a test. Emotionally, there is something almost human in our reaction to it. Beneath the equations and error margins lies awe, a quiet, uncomfortable recognition that maybe we are staring at something truly alien. Not in the sense of fiction, but in the sense of encountering a reality beyond comprehension. Scientists who once dismissed the idea of non-natural origins now speak in cautious tones, acknowledging that the word artifact may soon lose its taboo. Because if this isn't random, then it's intentional, and that changes everything. Intention implies design. Design implies purpose. And purpose, out there, across the vastness of interstellar space, implies intelligence. The more the data accumulates, the more Atlas feels like a message hidden in motion, an experiment to see who is paying attention. Its perfection mocks coincidence. Its persistence defies entropy. And its silence, that chilling absence of outgassing or noise, feels deliberate, like a secret waiting for the right moment to speak. For the first time, we are not asking how it moves, but why. Every line of code in NASA's orbital simulations ends the same way. Unexplained behavior. But maybe that's the point. Maybe we are the ones being observed, our instruments and intellects measured against something infinitely older and wiser. And now, as December 19th draws near, the sense of anticipation borders on dread. That is the date when Atlas will make its closest pass to Earth. Its trajectory bringing it into the range of nearly every major telescope in existence. The world's observatories are preparing like witnesses before an unveiling, aware that what comes next might rewrite the history of astronomy itself. What if the object glows brighter? What if it remains silent? What if it does something else entirely? Something we have no vocabulary for. The countdown continues, and as it does, a single question grows heavier with every passing night. What's waiting to be revealed when 3I Atlas finally comes close enough to look back? There is a certain poetry in how history repeats itself, especially when it does so across the silence of the stars. In 1977, a radio telescope at Ohio State University picked up a signal so sharp, so deliberate, that it changed the search for extraterrestrial intelligence forever. The sound lasted just 72 seconds. A narrowband radio burst from deep space, precise enough to slice through the static of the cosmos like a whispered name in a storm. The astronomer who discovered it, Jerry Eman, circled the data printout in red ink and scrawled a single word in the margin. Wow! For decades, the wow signal became both a promise and a ghost, a hint that something intelligent might be out there, watching from the constellation Sagittarius, waiting for us to notice. It faded as suddenly as it appeared, never repeated, never explained. Until now, when the trajectory of 3I Atlas was first plotted, it seemed like any other anomaly, an interstellar traveler approaching from a random direction in the Milky Way. But as its precise coordinates were refined through data from SOHO, Hubble, and the Virtual Telescope Project, astronomers realized something unsettling. The arrival vector of 3I Atlas traced back to the same region of Sagittarius where the WOW signal originated nearly 50 years ago. The odds of that coincidence are so infinitesimal that even the most conservative scientists couldn't ignore it. In the vast three-dimensional map of space, Atlas was not coming from just anywhere. It was emerging from the same celestial neighborhood that once sent us humanity's first possible message. It was as if the same sky that whispered "wow" in 1977 had spoken again. This time not with a radio pulse, but with a physical emissary. The possibility electrified the global astronomy community and terrified them in equal measure. Could 3I Atlas be a continuation of the same event? A delayed response or a material manifestation of the intelligence hinted at all those years ago? Some researchers suggested the connection was poetic coincidence, an illusion created by the mind's need for pattern. Others, more daring, proposed that this was no accident. The trajectory, they argued, was too exact. If Atlas were artificial, it might have been following a preset route, a long-range relay orbit that intersects our solar system on a recurring cycle spanning decades or centuries. The idea took root in late-night discussions between SETI veterans and plasma physicists, where whispers grew of a cosmic repeater, a probe designed to transmit or receive across time, not just space. A few theorists went even further. They suggested that 3I Atlas might not be the originator of any signal, but a node in a network, a kind of interstellar waypoint. In this model, the WOW signal wasn't a call, it was a ping, a handshake between distant machines. Perhaps the signal we detected in 1977 was not aimed at Earth at all, but at this object. And now, nearly half a century later, the object itself had arrived, either continuing the communication or awaiting confirmation. This notion sent shivers through the scientific community. If the WOW signal was a broadcast, then 3I Atlas could be the receiver. And if it was the receiver, then it was built to listen. The skeptics fought to keep the debate grounded. They pointed out that Sagittarius is a dense region of the Milky Way, home to billions of stars and natural radio sources. Statistical coincidences are inevitable when one looks deep enough into the sky. Perhaps the WOW signal was nothing more than a passing transmission from a pulsar or a reflection off space debris. Perhaps 3I Atlas's alignment was nothing more than the geometry of celestial chance. "We mustn't let wonder replace discipline," one NASA scientist said during a private press briefing. But the counter-argument came swiftly from those unafraid to confront the extraordinary. What if wonder is the discipline? What if, in our eagerness to dismiss the impossible, we are ignoring the only evidence that truly matters, the pattern itself? It is difficult to ignore how elegantly the puzzle pieces fit together. The WOW signal emerged from Sagittarius in 1977, carrying with it a mathematical purity that still resists natural explanation. Decades later, from that same quadrant of the galaxy, an object appears, metallic, deliberate, emitting blue light where no heat should exist, accelerating where no gas can vent, reflecting polarization patterns like engineered panels. Even for the staunchest realist, the symmetry is haunting. Each anomaly deepens the sense that 3I Atlas is part of something far larger than a simple interstellar fluke. The question that lingers at the edges of every scientific paper, every late-night telescope session, is no longer whether the object is natural. It's whether it is trying to communicate. And if it is communicating, then with whom? Humanity's first instinct is to believe the message is for us, to romanticize the possibility of contact. But the data offers no comfort. The pulses it emitted before its approach, the acceleration that defied physics, the perfect orbital insertion between planetary giants, none of it suggests invitation. It suggests observation, monitoring. The object behaves as though it's following instructions, as though it's enacting a cycle older than our civilization itself. Perhaps it's not here to talk to us at all, but to confirm our existence, to mark that the solar system is still active, still producing electromagnetic noise, still alive. And so, the scientists wait, divided between reason and faith, as the object drifts closer. The chatter in research channels has grown quiet, replaced by long silences and unspoken fear. For those who still dare to look at the data without flinching, a single thought remains impossible to shake. If this thing is a messenger, then the question we should be asking is not what it's saying, but who it was sent to, somewhere beneath the public face of science, buried in private message boards, encrypted academic chat rooms, and late-night theoretical exchanges between physicists who no longer trust their own equations. A strange new idea has begun to take root. It has no official name in journals, no peer-reviewed paper to its credit. It exists in whispers and anonymous posts, in sentences that begin with "off the record." They call it the mirror galaxy hypothesis, a theory as unsettling as it is elegant. According to this underground school of thought, 3I Atlas is not a random visitor at all, but part of a vast, self-regulating network that has been silently observing the galaxy for millions of years. Its function is not exploration, but evaluation. Its purpose, to measure civilizations that reach the nuclear threshold and determine whether they are worth preserving or worth erasing. The idea grew from a chilling pattern noticed by astrophysicists outside the mainstream. In almost every historical instance where a species begins manipulating atomic energy, strange cosmic phenomena appear soon after. Brief, transient events that seem to defy natural explanation. The timing, they argue, is never random. Earth's first nuclear test in 1945 was followed within decades by the WOW signal. Similar bursts have been noted near other candidate exoplanet systems thought to harbor life, often synchronized with what appear to be energy releases or atmospheric anomalies. The theorists suggest that these events are not coincidences, but responses, that somewhere, hidden across the light years, a mechanism is always watching, listening for the telltale signature of a civilization learning to split the atom. Once that milestone is reached, the system pings back, not as a threat, but as a record, a silent acknowledgement that we have been seen. The mirror galaxy hypothesis imagines an ancient intelligence that long ago seeded the Milky Way with autonomous probes, sentinels the size of small moons or comets, each designed to awaken only when a civilization emits a specific combination of frequencies, like the unique fingerprint of atomic detonation and digital communication. When that threshold is crossed, the monitor activates, shifts course, and begins observing, not communicating, not attacking, just watching. In this context, 3I Atlas's behavior takes on a new meaning. Its acceleration, its impossible stability, its calculated avoidance of Earth, all of it fits perfectly with the idea of a probe designed to maintain distance while recording everything, like a cosmic auditor checking in on a species that has just joined the list of civilizations capable of destroying themselves. To some, this theory is terrifying. To others, it feels inevitable. After all, any intelligence advanced enough to travel between stars would not need to invade or announce itself. It would simply observe, assess, and decide. The very concept of a silent gatekeeper has sparked a philosophical crisis in parts of the scientific community. What does it mean for humanity if our greatest discovery is not what we found, but what found us? Are we the observers, or are we the observed? For centuries, our telescopes have pointed outward, searching for signals in the void. But what if, all along, the eyes were already pointed inward, ancient and unblinking, watching the moment we became dangerous enough to notice? Cinematically, the imagery is haunting. Imagine a galaxy mirrored against itself, one side biological, the other artificial, life and its reflection. Each technological species unknowingly signals its arrival to the network by splitting the atom, like striking a cosmic gong. And from the dark spaces between stars, probes stir. They do not shine. They do not speak. They simply drift closer, adjust their trajectory, and begin their work. Humanity, in this telling, has already been catalogued. Every radio broadcast, every atmospheric detonation, every whisper of digital transmission may have been quietly logged by a machine built by something that predates us by eons. The emotional weight of that idea has left even hardened scientists uneasy. Maybe contact has already happened, one theorist wrote, and we just didn't recognize it. The realization cuts deeper than any alien invasion fantasy because it implies powerlessness. Not the drama of conquest, but the indifference of surveillance. We are not the center of the story. We are an entry in a database, and 3I Atlas, hurtling toward its December encounter, might be the most recent evidence of that ongoing audit. Its every movement, every flash of blue light, every deviation from predicted orbit could be part of a protocol older than our species. As the days tick by, the speculation grows louder. December 19th is no longer viewed merely as a date of observation, but as a potential contact window. Astronomers count down the days like seconds on a clock no one can stop. 42 days left, then 31, then 19. And through it all, Atlas keeps accelerating. No deceleration curve, no fading signal. Just that eerie, unwavering momentum, as if it knows exactly where it needs to be and exactly when it must arrive. The thought chills those who dare to voice it. If this is part of the Mirror Galaxy network, then its schedule was written long before our species even began to dream of flight. In the final analysis, the hypothesis may never find proof, but it doesn't need to. It has already achieved something profound. It has forced us to look at ourselves not as explorers gazing outward, but as a young civilization standing under an ancient gaze. If 3I Atlas truly is a monitor, then its silence is not ignorance, it is judgment. And as the countdown to December 19th draws near, humanity faces a new kind of cosmic question. Not whether we are alone, but whether we have already been measured, recorded, and found wanting. The world now waits in the longest silence it has ever known. As December 19th draws closer, the date that astronomers have marked as the closest encounter between Earth and 3I Atlas, an eerie stillness has settled across every observatory dome and mission control room on the planet. For months, the object has remained utterly silent. No radiation bursts, no chemical trails, no outgassing jets. Nothing. The telescopes see only a pinpoint of cold, unwavering blue light, moving with impossible precision through the void. It's not the light we fear anymore. It's the silence. In a universe defined by noise, by explosions and collisions, and the constant hum of stars being born and dying, silence is unnatural. Silence means control, and whatever 3I Atlas is, it is controlling itself. The world's scientific infrastructure now orbits this one mystery. In Chile, the Atacama Array is recalibrating its detectors to monitor every wavelength within range. In Hawaii, the Keck Observatory has reserved every hour of sky time it can afford. The James Webb Space Telescope, designed to peer into the birth of galaxies, has quietly repositioned to track the strange interstellar traveler's trajectory. Even amateur astronomers operating from rooftops and dark rural fields have turned their lenses toward the object, waiting for any flicker that might break the monotony of its motion. Every eye on Earth, from backyard telescopes to orbital giants, is locked on the same speck of blue drifting through the cosmic sea. The sense of global synchronization is unlike anything in modern memory, a species united not by hope or conquest, but by curiosity and fear. There are no official statements from NASA, no public updates from ESA, no comforting words from world leaders. The agencies have gone quiet, issuing only sterile phrases about ongoing data review and anomalous orbital behavior. But silence from institutions only amplifies the noise of speculation. Online, millions of people are tracking the countdown in real time. Conspiracy channels, science forums, and global news networks all echo the same questions. Why hasn't Atlas emitted a tail? Why is it still accelerating? Why is every model predicting that it will pass perfectly between Earth and the Sun, down to a fraction of a degree? It's as if the object isn't following a natural orbit, but executing a maneuver. And if it is, then someone or something is behind the controls. Among the scientists still willing to speak openly, there is a quiet consensus forming. Whatever this object is, it has no interest in communication, at least not in any way we understand it. There are no signals directed at Earth, no radio noise, no energy bursts. It moves as though Earth is just one waypoint on a route written into its memory long ago. The silence feels deliberate, almost ritualistic. Each time data from the Virtual Telescope project comes in, confirming that nothing has changed, no flare, no shimmer, no fragmentation, the tension deepens. "It's too perfect," one researcher said during an off-record call. "Comets decay, asteroids drift, ice melts. But this thing, it behaves like a machine pretending to be a rock." In the observatories, fatigue and awe blur together. Astronomers sleep in shifts beside their monitors, chasing a moving enigma across the sky. Every update from the automated trackers carries the same haunting signature. No deviation, no decay. Its path remains flawless, its temperature stable, its albedo constant. As the hours slip by, one truth grows harder to ignore. If 3I Atlas were natural, it should have changed by now. But it hasn't. It is still the same as it was when it first appeared. Clean, cold, metallic, deliberate. And so, the countdown continues. 48 hours. 36. 24. Soon, it will make its closest pass, skimming within 167 million miles of Earth, a distance that feels close enough to touch in cosmic terms. Some expect a sudden burst of light, others a radio pulse, perhaps even a gravitational anomaly that will ripple through the instruments like a cosmic heartbeat. But many fear nothing will happen at all, that it will glide past silently, never answering, never acknowledging us, leaving humanity staring into the darkness, unsure if it had just witnessed a beginning or an end. In every corner of the planet, there is a shared, fragile awareness that something historic is about to occur. Whether it's an astronomical event or a revelation that shatters our understanding of existence itself. The night before perihelion, observatories will stay awake. Cities will dim their lights, and billions of humans will look upward, their breaths caught in the same question. Will it pass by quietly, or will it finally answer back? The silence stretches, electric and infinite. Somewhere in the void between the stars, a metallic fragment from another system continues its steady, impossible glide, as though following a script written before our species learned to walk upright. If it does nothing, that silence will echo for centuries. But if it speaks, if even for a moment it breaks its calm, then history will divide cleanly into before and after. So, stay alert. Stay watching, because if what we are seeing isn't natural, then history didn't just change in a textbook. It changed while you were watching.